Welcome to my channel, guys. Today is my first episode. I'm going to cover most of the maths topics, but I thought I must start with the grade 12 papers. But going forward, I'll be doing maths in general. My goal really is to help those kids out there who are at school and doing maths, but just to give a different perspective on different methods when it comes to maths. So I hope you guys will enjoy the channel, and please subscribe to my channel, and I hope you will learn a lot in this channel. Now today I'm going to do a grade 12 past metric paper of 2018 November, and I hope at the end of the day one will have learned a lot. So let's get into it. We're going to start with question 6 of paper 1, maths paper 1 of 2018. So it's very important that before we can start any question, we must start to read the statement so we can understand what is going on. The question 6, it says, in the diagram below, A and B, this point are x-intercept on the graph of f of x is equals to x squared minus 2x minus 3. So the graph is parabola, and then it's concave up. A straight line of G, which is this line, through A cuts F at C 4 and 5, and the y-intercept at 0 and 1. M is a point on F, and N is a point on G, such that MN is parallel to the y-intercept. So to the y-axis, and MN cuts at T, cuts the x-axis at T. All right. So let's go to question 1, question 6.1, which says we must show that g of x is equals to 1. So g of x is equals to x plus 1 is this straight line. Just by looking at the straight line, you can therefore see that the y-intercept where x is equals to 0, y is equals to 1. And we can get a gradient of the straight line, which is y2 minus y1 over x2 minus x1. Can use these 2 points even that point. But we don't know our both coordinates of point A. So we can use this point there. Y2 is going to be 5, then minus y1 is this one, and y1 is that y-intercept, which is 1 over x2, this point which is 4 minus 0. 0, we take it from here because in the y-intercept x is equals to 0. 5 minus 1 is 4 over 4, which our gradient in this case is going to be 1. Therefore, (6.1). Sorry about that for deleting. Since we got our gradient m to be 1 and our y-intercept to be also 1, therefore our equation is going to be g of x is going to be 1x plus 1. It's the same as x plus 1. But those are the steps, guys. Let's go to 6.2. In 6.2, we have to calculate the coordinates. As the question has said that A and B are the x-intercepts, therefore, for x-intercept, we know that y is equals to 0. Therefore, to get two coordinates, we should say x squared minus 2x minus 3 is equals to 0. Then we factorize the equation, which is going to give us x minus 3, x plus 1, because when you add minus 3 plus 1, you're gonna get minus 2, the coefficient of x, and then when you multiply positive 1 and minus 3, you're gonna get minus 3. Therefore, x is going to be minus 1, or x is going to be 3. Therefore, our coordinates for A and B, A is going to be, because it lies below 0, it's going to be minus 1 and 0, and then B, it should be 3 and 2, 3 and 0. X should be 3, y is gonna give us a 0. That's about it, guys. Our coordinates for A and B are as such. X coordinate for A is minus 1, y coordinate for A is 0, and the list go on. Thank you, guys. We can move then to question 6.3. Question 6.3. It says we must determine the range of f So I believe this will be pretty simple, because our range, we're going to get it from the turning point of the graph. The y coordinate of the turning point of the graph is going to give us the range, and in this case it's going to be a minimum because the graph is concave shape up. Therefore, this is how we're going to get the turning point. The x-intercept, x is going to be minus b over 2a. Then we replace such. Our b is going to be minus 2, and then our a is going to be 1. We take the coefficient of x squared and the coefficient of x. We replace them. And the answer we're gonna get is that negative times negative is positive. That is going to give us positive 2. 2 times 1 is 2. Then the x coordinate of the turning point is gonna give us 1. And we can therefore replace our 1 to x squared minus 2x minus 3 to get y. Then y is going to be 1 to the power 2 minus 2 times 1 minus 3. So 1 minus 2 minus 3 is therefore going to give us the answer, which happened to be minus 4. Therefore, since our turning point is 1, x coordinate is going to be 1 and y coordinate is going to be minus 4, which is here. So our range, the minimum value start from minus 4 up to infinity. So all the values from minus 4 up to infinity, they will satisfy our graph. So we should therefore say our range, its y is more than or equals to minus 4. So that's how we go about it. I hope you guys have learned a lot, and we can therefore go to 6.4, which will be our last question. Okay guys, let's do 6.4. 6.4, we are given that mn is equals to 6. Therefore, we must determine the length of OT if now t lies on the negative axis, and we must show all the working, all our working. This is how we'll go about it. If you can look at the length mn, actually lies between the two curves f and the g. So if this graph minus that graph, that is because the graph is below, we're going to get that difference of 6. So this is how we to go about it. We must say x squared minus 2x minus 3, which is of course the graph f, then it must minus the straight line, which is x plus 1. The whole subtracting part of it is going to give us the length of 6, which is mn. So in this case, we will be able to get the coordinates of t, because we are already told that t lies on the negative x-axis. Therefore, this is how to go about it. Minus 2x minus 3 equals to minus x minus 1. We bring that 6 this side, it's going to give us 0. Therefore, x squared minus 2x, we add it with that x, it's going to give us 3x. Then minus 3 minus 1 minus 6, it basically gives us minus 10 equals to 0. So we factorize. In this case, I will choose 5 and 2. Minus 5 plus 2 is going to give us minus 3x. And then multiplying 2, positive 2 and minus 5 is going to give us minus 10. Then we solve for x. X is going to be minus 2, or x is going to be 5. But in this case, since we are given that t lies on the negative x-axis, therefore the x coordinate of t is going to be minus 2, but the y is going to be 0. Alright? Because it lies there on the x-axis. Then that means now the length is going to be 2 units. A length cannot be minus 2 units, but it's going to give us 2 units. That's about it, guys. I think it is clear and one have learned a lot. Let's do the last question, which is now what you call 6.4.2. After we get this length, we must now write down the coordinates of n. Right there. Right there. Just by looking, it's 2 marks. It's very easy. 6.4.2. It was said initially that mn cuts x-axis at t. So the x coordinates of m, of t, of n is going to be the same, which is what? x is going to be minus 2 there. Therefore, because n is a point on G, we're just gonna take the graph of G y is equals to x plus 1. We replace what you call x minus 2 plus 1. Minus 2 plus 1 is going to give us minus 1. Therefore, the coordinate of n, simple, is going to be minus 2, minus 1. And it makes sense because, as you can see, the n also lie below the x-axis. So there, it's going to be minus 1. That's about it, guys. Thank you very much for listening to my channel. Please subscribe. I'm looking forward to doing a lot of metric papers and a lot of mathematics. Thank you for tuning to my channel.